But the idea was we put a server here into the network and you can access it. That's why the name was Alaska and not Alaska Dash Software. And they're right now working on the network to make it real. Okay, so let's start. First question, how many of you are already using SQL as a data access language, let's say, more or less on a daily basis? 1, 2, 3. In which context? In context of the AES server?
Yeah, mostly AES.
We're using Boris' SQL Express.
I see, okay. Somebody else? Okay, so this is the SQL group. We all need to look at them. So this is our primary source of information. Okay. Can somebody please close the door if possible? Thank you very much. Let's start. This session is about SQL for Xbase developers. That means, I assume nothing in means of existing knowledge about SQL in general or specifically about some type of DBS SQL Server systems. But it also means that I want to introduce you into this data access language in the context of existing knowledge. It starts already here, Isern developers. When we talk about data access, then the truth is Xbase is not a data access language. Xbase is a programming language, it's a forced G. And Xbase, such as DBase, always had so-called navigational data access commands embedded in the language, in the Xbase language. This is called Isern because it's index sequence local set master. So it starts with, and that's where I want to start with this entire section. I want to start with you talking about terms. I want to clarify some typical misunderstandings in means of what is SQL, what is SQL not. Then, we look into SQL in the context of Xbase 2.0, the different flavors, so to speak. The keynote I mentioned already. We have Universal-SQL, we have Unified SQL, and there's also pass-through SQL. This is what we're doing with AES, for example. Then we need to talk a little bit about the theory. We need to talk about creating data, manipulating, and working with data in general. So let's start. On the left side, I have used traditional, let's say, Isern terms, or in Xbase, or existing terms. Field, it's record, it's table, it's database. Very often in text report, people say, the system does not open the database. The person means the use does not successfully open the table. The use opens the table, the use does not open the database. A database is always a collection of tables and much more. We need to set the terminology straight. Why? Because when we use the proper terms, we can talk with other people. If we use different terms for different things, or same things, then we can't efficiently communicate. So it's clear in Isern terminology we have a field, which means it's one field which is part of the record, so to speak, part of our structure definition in the Isern table. In the SQL system, they also have the field, but the field is different to the column. The field is in SQL terms the intersection of the row of the column, because it's the concrete value. The concrete value is the field. And that's how in Xbase++ I always wrote my code. Field, alias, blah blah blah, field name. I want to have this concrete value, not a row, a column. While the term column has no corresponding terminology in the ISAM world, where in the SQL word column is used to describe the column of the table, where a table is a collection of columns. Database is a set of tables, clear. A table is a set of rows, seems to be logical too. And a row, it's clear, it's a set of fields because we are talking about concrete values now. We're talking about concrete row. It's not abstract, than column. So please use table, database, field in the proper way, which means database is always a collection of tables. That's the core message here. Because otherwise it gets difficult. Visual Foxborough, for example, has the concept of a database. It's called database container. It can be understood such as a subdirectory in which there is a collection of dbef and cdx files, plus an additional file which describes the correlation between these tables. So Foxborough always had a real database. Clearly never. Next term. We are always talking about file-based data access. Well, it's file-based databases. It's also a term which is used. But the truth is, even a SQL server does store its data in a file on the hard disk. Of course, there are some systems which use, which can avoid file systems and can use raw data. But these are special systems. In general, any data is stored in a file. We are not file-based. The term ISAM is the proper term when we refer about our data access methodology we are using since decades. It's index sequential access method or navigational data access. That's what you are doing in the Xbase++ language or in all the other Xbase languages since decades when you are working with data. Navigational data access, ISAM, that's it. It's nothing more, nothing less. And when we compare, we did compare ISAM, navigational data access, compared with SQL, relational data access approach. That's what we are allowed to compare. The big difference, of course, is in ISAM, tables have a fixed record length. That's the basic idea of ISAM. And there's another hidden aspect in ISAM, which sometimes drives us crazy. It's about multi-user. With ISAM, you are dealing with the multi-user aspect. That means I'm locking a record, I'm unlocking a record, I'm ensuring that there are no phantom reads, that there are no lost updates, and all things like that. And I do that by implementing code on the table to lock rows, to lock records, or entire tables, or whatever. In SQL, you don't do that. You are isolated from this difference between single and multi-user. However, you have to deal with something which is called isolation levels, which you need to carefully select. But so let's continue with clarifications. First of all, SQL does not necessarily mean client-server. Client-server is a concept that just means instead of accessing a file directly, there is another party, the so-called server, which accesses the file. The level of abstraction of the file access, that's where the terminology in SQL versus ISAM comes into the game. We all know I can have dbef entities or cdx files shared over the network, and then it gets too slow. I want to have more performance. I use the ADS server, which gives me the client-server approach which means I now can have the benefits of client-server model in means of lesser traffic on the network because more work is done on the server. But still, we are using with the ADS server the first step, ISAM, if we don't change our code. It's indexing to access, it's navigational data access. It's not related to SQL. Many people, when they have problems in their application, for example, data corrections or things like that, they say, I need to go to SQL. Because SQL is more robust. No, it's not. It's not SQL. The fact that SQL solutions are more robust relies on the fact that most, if not all, SQL systems are delivered as a SQL server. So they're robust, they're more stable, more reliable, and that connects because of the client-server architecture. Because of that, but you get the same reliability by just moving with your existing solution to the advantage server, for example, because it's client-server too. And so it gives you the same reliability and the same recovery capabilities in almost cases, including transaction capabilities. We can do that later. So SQL is not related to client-server. So if you think SQL resolves through reliability or stability issues in your application, it will not. Client server can do that. This you can have without going to SQL. It goes even further. SQL means generally that a SQL server is required in means of a dedicated system, depending on the amount of users, but not even to have a dedicated server. Second, due to the level of abstraction, your SQL server needs more resources than the advantage server, for example, which means when we talk about real-time applications or applications which need to perform many updates in a small period of time, let's say 5,000 updates per second, then it's getting difficult to do this with a SQL system. I mean, when I use here on my laptop ISAM, DBF, CDX tables, I can easily do 25,000 record updates in a second, no problem. Local hardware, not a big deal, so to speak. With a SQL system, that amount of transactions, it's impossible. So, moving just to SQL may implicate other problems in specific application scenarios, such as real-time data gathering. So, it makes no sense to move these type of systems to SQL. SQL also means three other aspects. It means not only, it's definitively not related to client-server. SQL is data access. SQL means data definition, like DB create, we know from the ISAM world. SQL means data manipulation, changing data, adding data. And SQL means accessing data and performing queries. So the SQL language strictly focuses on these three aspects: data definition, manipulation, and access, while the ISAM basically always just lives in the data access and the data manipulation area, and the data definition area only in a restricted way that we could create tables which are fixed typed. Oh, they have fixed type, but that's it. In SQL, I can define the not only data types, but default values and so on. This is a feature which is mostly related to a capability a SQL system needs to have. It's called the dictionary. There are ISAM systems such as flavours, for example, which also have a dictionary and which then can benefit from the data definition. But in general, SQL is equal to data definition, data manipulation, and data access. This comparison, SQL versus ISAM, it's clear. You can compare these two things because they are two different data access methods, basically. The SQL world is relational, it's result set oriented. You always have a snapshot of the information, while the ISAM is more real-time data oriented. I always go through to the concrete position of the information in my table by navigational data access. And the comparison SQL versus Xbase++, which sometimes I hear, and people ask how to compare Xbase with Xbase++. SQL with Xbase++, forget about it. There is no need to compare because Xbase++ it's a forced GL and SQL it's a data access language. And it's clear where SQL nor ISAM are built complete, which means they are just languages for data access, data definition, or data manipulation. You can't create real-world applications with these languages. So we need to have another development. Let's start with a little bit practical look into. This is a SQL Server system. It's a blue box because I like to call blue. But we can look at it as a black box. Generally, when I use a SQL Server. But in our case, for understanding, we want to look into how this black box works. By doing this, we start with sending a typical simple SQL statement to this SQL Server. In our case, it's select star from customer where city equals Frankfurt, which means, dear, friendly, my beloved SQL Server. That's the select. Return me all, that's the star, from the table customer, where, and this is like a filter condition, where the column city equals Frankfurt. Which means we get now from the SQL Server the result set, which means all fields, all fields from the customer table which relate to a row at which the field city equals Frankfurt, which can be a large amount of data, of course. And that's a big difference in the first step. In the ISAM world, we navigate on a concrete table on the hard disk. And we know when we are at this location and when I have logged that record, that's the real information. SQL systems work different. They return a result set. Here, in that case, they return us a snapshot. Basically, on the client side, we get a copy of all the information on the server. But this snapshot, in the time frame while being delivered from the server to the client, can be outdated. It's clear. In the time frame while the data travels from the server to the client, and then it's in the memory of the client, or result set, because it's set-oriented SQL. It's already outdated because somebody else changed. Maybe one customer moved it from Frankfurt to Berlin, which may happen. And then where's the wrong data? This is normal, and nobody cares in the SQL world about these general situations, I would say. There are some specific cases, such as updates, credit debit scenario, or other things where I need to use transactions, or where I need to change isolation levels to cover this real-time data aspect, so to speak. But in general, I'm just retrieving snapshots of data, which maybe are there. So that's the first thing. So when we send this statement to the SQL Server, then the SQL Server does his black magic and returns the result set. But what's the black magic? In the first step, the SQL Server has internally something which is called the command processor. This system takes this SQL command, which has been sent from the client to the server, and reads it, checks if it's syntactically correct, semantically correct, means of, for example, does this table exist in the current database? And then creates some, let's say, data structure, some type of abstract description of this query. For example, in our case, the star and the select star from became the all keyword in this data structure. Or the table customer is the table and the expression, so that's it. It's just an abstract description, let's let's say, of our query sent from the client. The next step, and that's the first big difference to, let's say, Isernhagen, is that because the SQL server knows the database, we learned before, SQL has a data definition, and the database is a collection of tables plus other rules and data information. Because of that, now the system, which is called Planner, works and takes this description of the incoming SQL statement and query and checks how the data model is outlined. And based on that knowledge about the data model, means that there's a DBF table, blah blah, there's a table with the customer field and so on. This planner creates code. Generally in the SQL Server, this type of code is P code or virtual machine code, which then gets executed by the execution. But this is an abstract code you can't read. But in fact, this code is exactly identical to what you normally write when you write Isernhagen code, because the result of the planner is our sequence of instructions which basically implement Isernhagen operations. So, in other words, the planner finally came up with that description. Open table customer, start at the beginning of table customer, scan until the end of table customer, and add the record, add any record to the result set, which where field city equals Frankfurt, because that was the select statement. So the planner takes the incoming description of the query and creates nothing more than normal Isernhagen code. It's virtual machine code, but it's basically that. In the next step, the SQL Server has another system, which is a little bit more intelligent. It's called the optimizer. The optimizer now checks if the data model has indexes. This is something we all know. We have a table, on this table we have this index, and this index. And when I write my code, I know exactly which index I want to use when to navigate as efficient as possible straight to the point where I want to go. Well, this is an abstraction. SQL Server is an abstraction, so it doesn't know that. And in the basic step, you don't have indexes on your tables. Anybody will tell you to forget about indexes on the SQL Server, because the more indexes you have, the slower the system runs. Why is that so? Because there's this central place, the SQL Server. And when you think about, let's say, a small table of our products in a small company, let's say the table of products is just 100 megabytes, which is a very big table of products, I would say, it's 100 megabytes. But this fits easily in memory. So what SQL Server can do is he just takes the whole table, the whole data of products or so into main memory. That's why he sometimes doesn't need an index. When a table grows, it needs indexes. If it's a small table, you don't need to care. It depends on the situation. But in general, the optimizer now starts to look into the meta model and checks if there are indexes which can help rewriting that original plan we have here. And in our case, let's assume we have an index for the column city. Then the optimizer rewrites our original plan like we always do when we write down our Isernhagen code. Because now the optimizer has reached the point where we are normal R, so to speak. So the optimizer now said, okay, there's index. So I can use customer with cities at the index. Again, now I seek to Frankfurt, and then I only have to scan through that small result set, which is way faster than scanning the whole table. The great thing with SQL is that I, as a developer, don't need to care. Because I, as a developer, ask what I want. I have this question, give me all customers from Frankfurt. And the SQL system decides how data gets to be collected and decides about the most efficient way. This is a simplification, it means of the optimizer, because we just talk about indexes. The optimization mechanism of a modern SQL service, such as PostgreSQL, for example, it's very sophisticated because any type of operation, the scan of the table, the C for predicate and the index, all this has an associated cost. Like in the business world, anything has costs. And the optimizer calculates the total cost for an operation, and then decides, when I remove this and add this, what's then the total cost? And based on this balancing of costs, the optimizer finally tries to create an optimized plan for an initial statement, or tries to rewrite the original thing. And finally, there is the executor, which is nothing more than a virtual machine able to perform seeks, all the navigational ESM commands we know since decades, because that's the executor. That's it. And then, down under the executor, there is a system which is called the storage manager, which handles the tables and indexes. That's what we call database engines when we talk about management of storage. So, as you see, in one way or another, any SQL server is always doing ISM. And this down here, when he executes the plan. The great benefit comes from the fact that I don't need to care about if there is an index or not. That I don't need to care about details in the data model, because the system knows, and then I can perform my operation, which allows me to write code instead of always running behind my data model changes, which can become a lot of work over time.
Last question.
Yeah.
You were thinking of having an index on the current city.
Yeah.
What if there is no index? Will this optimizer create a temporary index for it?
Yeah, well, this depends on the SQL Server system, basically. Some are intelligent, for example, it has some add-on models which enable you to do that. In general, it's a job of the administrator of a SQL system to look how the SQL Server is used, to determine when to create indexes for which scenarios. Okay, application designers do so too, depending on the complexity of the application and the requirements of the application. But it's basically your decision, and it needs to be done upfront as application design.
Or it can be done on the flow.
Huh?
Or it can be done on the flow. Create a temporary index, retrieve the data, and then restore the index.
You can do that too. For example, what you can is you start to deploy your application just with one or two indexes, and over time, depending on the queries which turned out to be required in the company or in this field of your solution, you can add new indexes or change existing ones. And you can do that, and that's the great benefit, without changing your application source code. That's the good thing. The bad thing is that, as always, when you add indexes, you add overhead to your transactions, which may lead to, it's always a trade. I mean, when you want to have very fast queries, then have as much as possible indexes. But if you want to have as fast transactions, and means updated insert operations, then just get rid of all indexes and put it out in the server. It's like an Xbase++. I mean, when I have 20 indexes for the same table, it needs more time to update one record than when I have just one index or none. It's normal. And the same decisions need to be done here too. Big difference still is it doesn't force you to change your source code of the application. And that's a benefit, because it reduces costs when doing application development in that area. So, from a general perspective, the big difference basically between SQL and ISAM is that in ISAM, your code says how information or how to deal with data. Where in the world of SQL, you're just saying what you want. And you say here, ideally, sometimes it's not as easy, but in an ideal world, you're always saying just what you want. And this abstracts your applications and your code, and therefore your investment, from the physical representation of the data model, which allows you to do performance changes or data model changes without code changes. But it's also clear this wonderful level of abstraction, as always, has price, and this is performance. It's not the case that when you compare ISAM as a data access pattern with SQL, that SQL is faster. The opposite is true. If we compare local file-based SQL and ISAM, SQL is slower. If we compare client-server-based ISAM with client-server-based SQL, then SQL will be slower. You can't get rid of that fact, because it's a level of abstraction. If you're a very good developer, writing good ISAM code, knowing your data model, you will always outperform the SQL system. It's clear, because there is no requirement for a planner, no optimizer. Your brain is your optimizer. You know it better than the many assumptions and heuristics inside the SQL system in that case. Of course, it still makes sense to move to SQL for a simple reason. Because there's a hidden jewel, so to speak, inside this abstraction. And this hidden let's go back to this scan here. When I write this code in Xbase++, then it can be very efficient because the ISAM engine and the storage manager can realize with heuristics that it's a permanent navigation forward, it's a table scan, and then he can increase the read ahead, and with one I/O operation against the hard disk, more records in one I/O operation can be read into main memory. And then it becomes faster and faster, so to speak, so caching gets increased. But because the database engine, the storage manager, does not know at our go-to line, at our do-while, at our if-field, at record blah lines, what really the semantics of this operation is. The database engine needs to do a lot of assumptions or have a lot of heuristics to optimize this process. Visual Foxpro was always a little bit more intelligent in that case. What we learned is that Visual Foxpro people don't write it that way. What they write is, they write use customer, scan for field city equals Frankfurt, and scan. So they have a special statement for that. Instead of writing do, while, and skip, and so on, they have a special statement for that. And the great benefit of that statement is that because of this statement, the underlying database engine gets knowledge about what the developer wants to do at this point. In Foxpro, because people are using scan and scan, they're telling the database layer, the storage manager, I want to scan the table, which for the storage manager means, okay, let's take as much main memory as I can and put the whole table in as large bunches as possible into main memory, because he wants to scan the table. This I can do as fast as in the main memory. So the fact that there is this abstraction against the underlying system helps the runtime to optimize. That's what I meant before with the benefit of SQL, even though there is this abstraction, because I'm on this abstract level against the runtime, where I say what I want. The runtime system, the SQL server, but also now the Xbase runtime knows what we want and can optimize for that operation, which in the past was not possible. Because in the past, we're talking about how to get the information instead of what we want. But when Xbase runtime knows what we want, it can feed into the whole BBF table into main memory. Just to give you an idea, if I want to have these 100 megabyte products table into main memory, it will cost me 2 milliseconds. When I want to read all 500,000 records of this 100 megabyte BBF table, record by record over the wire, it costs me around 200 seconds. There's a big difference. This difference comes from the amount of request reply, pages, traveling forward and backward for each record operation between client and server, so to speak. When I just feed in the table, it's one request, give me the table comes. It's much more fast. So, that's the basic paradigm shift we have in front of us. The move from saying how to get data into saying what we want. That's at the same point the big benefit of SQL. So now let's compare two different data access languages. We learned previously that there's data definition and data manipulation. This is a generic terminology describing the area into which constructs of a language fall. So when we look into the data definition side, we have this create from blah blah index on set relation or this DB create stuff for Isern. And for SQL we have basically create table, drop table, other table, which is nice because we can alter tables. Another benefit, when we want to change right now in the Isern mode table, we need to upload it, we need to recreate the structure and load the data from one table to another and so on, which is a difficult task. In the SQL system I have a ready-to-use operation for that, which does a lot for me. I can even create special statements which then automate the entire transformation process, even when I move from, let's say, integer into a character. I can do that. And then there's the data manipulation languages, which is what we are mostly interested in, because data definition, well, I use this tool, others use that tool, some people use data designers, so. And in the data manipulation language, we have on the Isern side always this replace, delete, seek, append stuff. And with the SQL side, we now have the insert, update, delete, and the select operation. The select is used to create result sets from queries. Insert, update, deletes are clear. I need the insert data, which is comparable to the append operation in the Isern mode. I need to update data. Clear, and I need to be able to delete data. But that's it. So for you, in front of you, it's just, if we forget about that, it's just 4 commands, 4 new commands. That's all. To move from Isern to SQL, so it's not a big deal. It's not so much. Okay, some of these commands can become very, very complex. Because they can be nested, so you have very often a situation that you are performing an insert using a select, or performing an update based on a select, or something like that. But we will do that. From this, let's say, generic view, yeah,
Stefan, is there an equivalent pack command in SQL?
Well, first of all, yes. Second of all, no. The point is, first, the pack command in Isernhagen or specifically in the Xbase database engine drivers, like DBF cities, and so on, serves two purposes. Purpose one is to get rid of deleteds, right? And the other purpose is to get rid of fragmentation of your table, which means of unused space. When we talk about a SQL system, it's getting much more difficult because, you know, they are always drawing this wonderful thing for the storage of a SQL database. And inside this database, there is an infinite amount of tables. So it's and all these tables can have fragmentation. So a SQL Server system has a much more strong demand for something such as a pack than is an application. It's unbelievably important for them. And they don't call it pack, they call it vacuum in most cases. Some of the systems even have commands which are called vacuum, which is just a different term for the same, but it's focusing only on the fragmentation of the storage, which means recycle unused space or compact data in a way that data accessed and used is at one place and usable space is at another, free space is at a different place. When we talk about the semantics of pack, it means of getting rid of deleted records. The bad news is this is not possible in SQL because SQL always deletes a record, there is no recall. So if you delete in SQL, it's gone. And there is no recall, so it's really gone. So this is a different issue. We will talk about this later on a little bit because so back from this, let's say, generic view about SQL and ISAM as data access methodologies and paradigms, let's look into the concrete SQL capabilities of the Xbase ++ 2.0, which I call SQL flavors. There are basically three. There is Universal-SQL, which allows you to have a select, insert, update, and delete operations for any used work area. And this is important for any used work area. That means it can be a use against the DBF table, it can be a use against a ASCII file, but it can also be a used work area resulting from a select against the Microsoft SQL Server. Any used work area can become a valid table source in a select operation in this Universal SQL. Plus, it's not only restricted to the work areas, it's also allowing to add arrays and objects to the input qualification. Initially we saw this select star from customers. And now you have select star from customers, where customers is a work area, which just is a DBF table. Comma, open bracket, a data, closing bracket, which is an array of data objects, array of objects. Let's say array of product objects you have. And then you can create where or joins between your in-memory data, your DBF table on hard disk, and whatever you want. And that's where the real power then starts to develop. Because I now can use the select statement or the SQL language, specifically the select statement, as a general proposed language construct to create any type of, let's say, result sets from any type of input data. And when we think about this, when you write business logic, for example, in your applications, in our application, how often do we create loops or logic which get us data together from different places, joins the information, creates aggregations, creates subtotals, and does a lot of spelling. An enormous amount of logic rewrite is of that way, or is of this kind of source code. And this we can now effectively substitute by using SQL in the language, because we can use the arrays, the objects, in any used work area. We even can create in-memory tables, which means I can create a table which is typed, in means of character, integer, numeric, whatever, which is only residing in memory, like an array, like a variable. It's a data structure just in your main memory. And this we can also use in our selects. So we have a lot of new opportunities to write our business logic much more efficiently, compacter, less dependent on the concrete data model, and finally faster.
Steffen?
Yeah.
Do I understand correctly that if you have a select statement, the result is actually a new work area?
You can choose if you want to have the result as a new work area, as a collection of objects, or an array. It's your decision. The universal select statement has an into clause, and there you say into alias, or into array, or into object. So,
Why is that with the into that's already in SQL for creating a new database? You can see it still supports that,
yeah.
right?
You mean, but we are talking about Universal-SQL, which is the SQL on the Xbase language level, only for the memory. There are Universal-SQL and Unified SQL are on the front side of the expression, so to say, select, star, from, blah, blah, where, and group, and having, and so on, they are identical. But on the back side, we will see it later, when it comes to correlation via session or into blah, 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 then it's different because it's two different flavors of SQL.
Yeah.
One is in memory, it's universal, and the unified is for more. So that's Universal SQL. And then there is Unified SQL, which has the underlying idea that we want to unify the different syntactical and partially semantical problems of SQL systems. The truth is, there is a SQL standard, and it always was moved forward and got added new features, but SQL Server vendors don't follow this standard. To be more precise, by definition, this standard is not precise. That's the agreement the vendors, which are in the standardization committee, had to have competition, which means it's just a theory that SQL equals SQL. The truth is that even when we talk about escaping of string literals in your expressions or behavior when it comes to logic, SQL systems are different. Complex queries between SQL systems different in result, partially. When you want to have one code for different SQL systems, you have to deal with two major areas. One area is syntactical differences, and the other area is the outcome of the query is not what you want, because the result of the query is different between different SQL members. The idea of unified SQL is at least to catch up with the syntactical differences in the language level, because otherwise you would have to write your SQL statements for each external SQL system in a different way. Talking about different string literals for strings or comparison operators, or even the simple thing, the concatenation of a string. I mean, it's different between SQL vendors. One used this vertical pipe, others a low plus sign. It's crazy. And it makes no fun to write SQL statements for each other SQL system. And so we came up with this idea to have a Xbase++ language conforming type of writing SQL statements, but have the database engine of Xbase++ rewrite that SQL statement. So what happens is that this is the unified SQL statement is rewritten by the database engine, which creates then, let's say, a Postgres SQL statement or a ADS SQL statement. So it's a job of the database engine to rewrite them. Yeah.
But how does the database engine knows if it is connected to an ADS or a MySQL or which way to translate?
Because we are here talking about this is the ADS engine and that's the Postgres.
Okay.
So the point is the database engines in 2.0 they have these statement rewriter class implemented right now. And basically we will document this class so you can even rewrite, create your own rewriters for other SQL dialects if you want. But we don't want to do that, we want to document it, and third-party vendors can do that, or professional users can do that if you like. The technology behind what we are doing is very sophisticated because it's just not a simple rewriting the statement. What happens in fact here is that, let's say you have a complex expression in your warehouse, and you're comparing with an array on the language, or you're comparing with a local variable. For example, you have where equals string, but writing a string in the SQL statement makes no sense. We are writing data-driven applications, so that should be a local variable passed into by the parameter to that function. Well, with Universal-SQL and Unified SQL, exactly that you can do. So you can really write where ccity equals ccity. It's a small c, large C for prefix, camel case, and this ccity is a local variable. And what happens then is this code block, which is this expression square, is transformed into a code block. The Xbase++, there's a new virtual machine inside the Xbase++ runtime, and this virtual machine executes the code block. But it does not really execute the code block, it does simulate the code block execution while knowing the context, like local, the stack, while knowing work areas and whatever. And this simulated execution of this virtual machine leads to not the execution of the operators, no, the execution of special state operator rewrite methods of the classes in the database engine. In this way, the database engine executes the code block basically in a virtual machine with a rewriter class coming from the database engine, and this finally leads to a new expression which is then conforming to the SQL, to the syntactical requirements and semantical requirements of the SQL server. A little bit weird.
So if we start with it, we have actually ready to use for Postgres and ADS.
Yeah.
But if we want to connect to Oracle or MySQL, we have to do to create.
If you want to connect to MySQL, I think you should change the tool. I don't like MySQL.
Well, whatever.
Kidding.
Microsoft SQL?
You need to write your class.
You're not providing.
Huh?
You're not providing.
No, we don't want to do that because we are not running after Microsoft. The truth is that if we would start to do that, we need to change each year all the stuff because that means they're always changing their stuff, and we don't have resources and money left just to run behind Microsoft. This is not our business. We want to protect investments of our customers, and we can't. Nobody will pay us for that. That's not possible. I don't think so. but it's easy. These statement rewriter class for the SQL Server, I don't think it's, maybe it's 1 week work for an average PhD programmer to catch up with almost cases or so. It's not so big. But the problem is, when you want to catch up with the new syntactic elements, the new behaviors, which Microsoft introduces almost many times a year, then you need to update always this class. And when I think about that, we would be in the position to do that for our customers, then first problem is we scale out, that's the term, which means doing this, for example, for one product is okay, but because at the same point in time, there are at least 10 different versions of Microsoft SQL Server at our customers' installation base, we need to maintain 10 different versions of this type of support. And who pays for that? It's the old trick Microsoft is always doing. They're moving their Q&A costs into the planet Earth. Just creating new things all the time instead of being backward compatible, instead of ensuring that new stuff works perfectly with old stuff. But by not doing so, they're reducing their Q&A costs dramatically because the largest branch is backward compatibility. But you can do it by yourself if you want. And of course you don't need to do it because there's also path-through SQL, which of course is basically exactly what more or less the SQL Express sometimes is doing. It's path-through. It's passing SQL statements as a string through the server. And that's, for example, how Fuchsbro also dealt with SQL. It's, by the way how almost all other systems and languages deal with SQL. They use path-through SQL. They have parameterized statements, which means inside string there's some special notation, such as a question mark with a number or something like that. And at this position, the parameter gets put into my execution engine of the SQL. This is path-through SQL. It's supported, and as that here with path-through SQL, you can reach any proprietary syntactical or whatever system, and of course you can with path-through SQL also reach your Microsoft SQL, MySQL, whatever you want with all the proprietary commands. But you don't have the freedom that you write code on the language level. You are dealing with strings. You have your problems that you write special utility or infrastructure code to handle with your input variables and input values coming from a parameter interface, virtuous linking, and adding this to your SQL statements. Yeah?
But can I combine the pass-through SQL with the Universal-SQL?
Yes, you can. You can use the results from the path-through SQL, which is again a result set, needs of used work area, and can use that again. Oh, that's a good idea. You're right. Genau, yeah, you can use that, the Universal SQL, to deal with the impedance mismatch with the language then. Because with Universal SQL you don't have the impedance mismatch, but with path-through SQL you have. But by getting your path-through SQL just the result set into the Xbase process work area and then using Universal, you're perfectly set. Exactly. That's a great workaround. So forget about writing this rewriter. It's limited, clear. His approach is perfect for anything related to query. His approach may fail when we want to have transactions spanning multiple tables, so to speak. Because then this approach is no more working, then we need to still go back to path-through SQL. But in the other cases, very well. Some other questions regarding the three subjects?
The last thing you mentioned, you said that if you want to use transactions for multiple tables, you have to go through path-through SQL.
Yeah.
So it is not possible to unify SQL.
Yes, they're not possible to unify because we are here talking about the data source, remote data source, in this case the Microsoft SQL Server. And there are transactions in Universal-SQL, but we don't have the ability to do distributed transactions, which is what we need to have when we want to have joined the transaction from the remote SQL server.
Right. Okay.
We have transactions, that's the other good interesting thing now on the Xbase language level. You can even, let's say, roll back your changes on the objects and erase, we say. But the cool thing here is that you have now transactions for the DBF tables with this layer. But it's in-memory transactions, and because our pass-through result set is coming from a remote data source, we need to have so-called distributed transactions, because this is not an Xbase interest. It's not working. So I've written it here. Universal-SQL and Unified SQL integrate with the language, the user-defined functions, locals, and so on. I even can use user-defined functions in where clauses or in projections on the Universal-SQL side. So I think let's have a look into this a little bit more in practice. So as I said, Universal-SQL is designed for work areas such as existing DBF tables or I don't know if in the meanwhile the server is up and running at which you can download the conference build, but independent of that, after my session this afternoon, which is a rehearsal of this session in the German language, I will upload all the samples also to this server at the download location, so you can download my sample code I'm working with you here, the sample data and the data model. So you can experience it with the conference build. So maybe we need first look into this. Slideshow from current slide. Oh God. This is not. I'm just trying to find a tool with which I can zoom into this data model, because I think before we start to look into source code, maybe we should have a look into, is there something? I think it's a good idea to look first into the data model. I will start up Microsoft Visual. Okay. I think these tools are not designed very well for
Control Plus.
Bitte?
Control Plus. Funktioniert nicht?
Ja, ja. Fit to window. Entries, entries. Full screen. I'm looking there, there needs to be some full screen view here. No way. Okay, great. So let's close. We need to do it this way. Okay, what we have done at Alaska Software, we looked for a data model, and because with SQL, it's crucial to have, let's say, a complete data model based on which the samples are working. It makes sense to have a data model because of sample applications. And so we looked what's the best source. And after a lot of discussions, we came up with this great idea, which is called Korean Session Company. But this is Korean Session Company, it's a large project. Because what we started is we designed an artificial company, which is not really existing, with all the operations, the people and so on, which needs applications such as back office applications, point of sales registration, cash registration applications, and all that type of software, which is then developed using Xbase DevCon and is artificial. But because we are talking about 2.0 and we need to release it now, we decided to do that here instead of having a super solution, having at least the intermediate solution. And so we get back to Visual Fox Pro and took the Northwind sample database from Fox Pro. And we not only took the Northwind sample database from Visual Fox Pro, what we did was we migrated over to DBF CDX tables usable from Xbase++. Then we created the SQL statements and migrated over to the PostgreSQL server. So we have a complete set of SQL statements giving us Northwind for the PostgreSQL. And finally, we moved into the SQLite engine, because the SQLite engine is the kernel of the Xbase++ SQL engine in the core. So we have the same data model also in this engine. So we have it on DBF tables, we have it on remote databases like the PostgreSQL, and we have it on the in-memory SQL, the SQLite. One database, one data model with symbol data for all different DBMS systems, which was a lot of work again to have this data model consistently and working. But we have it, and I also will upload it then on the conference server in the afternoon, because then you can play with it. But as always, to give you an idea, it's a very small data model. It has customers. Can you read this? Yeah. Okay. So it has customers with a primary key customer ID. It has products with primary key product ID, with a category, which is such as beverages or seafood, which is with a category ID as a primary key. We have orders with order details, and this is the order header, so to speak. We have shippers. We have suppliers for our products. We have employees which took orders. We have employees which are associated to territories. And because this is an end-to-end relationship, we have here the employee territories table, and we have the territories here. And we have the regulars for the territory. So it's wonderful because we can create a lot of select joins with this data model. We can even create views and so on. So, because I'm starting with Universal-SQL, I'm starting with Universal-SQL. What I have here is a symbol in line 34. Is anybody able to read the source code on the last line? Okay, right. So at line 34, we just use table categories DBF for sake of happiness. I'm checking if it's used, and dump out alias and structure, nothing dramatically. And then the first interesting thing starts here. I'm doing the following. I'm just creating a select product ID, product name. Rule number 1, never use a star. When you are working with SQL, don't do this. Anybody does this. And then they deploy applications at their customer sites. And then customers complain. And then administrators complain. And then other people complain. And finally it turns out they complain because of performance. And then somebody looks into this and finally decides, oops, this table has 30 columns. And just to get the name and the ID of a product, I'm transferring, because we're talking about result sets in SQL, result sets. We are transferring all column data for all these rows to the client. Oops, a lot of data. When I care about the ID and the product name, I only ask for ID and product name. I always say what I want, not more, not less. Because think about it. We're talking here about transfer of data from server to client, and we're talking about result sets. Result sets can become large. If I have all the columns in my result set, they're becoming even larger. It's an additional dimension. So while it's true, it's very easy to write all or star, don't do it because it costs performance. And the most efficient optimization in your applications is simple. Just ask for what you need and not ask for all. I know it's difficult, we are all kids, we want to have all, I get it, but please try to resist. So we do here a simple select, product ID, product name from products table, which is in our case from products work area, because we are talking here about Universal-SQL, cut ID into a data as array. So that's this part of the statement. It's why this statement is a universal SQL statement. Because we say into a data as array, we can say into a data as objects, or we can say into as work as alias. And then it's a work area. I use this and just dump out the message box, which is not done. We have here category ID 2, and that's it. The next statement, it's a little bit more to read, because what I'm now opening is I'm now asking the products and the categories work area. We remember products have a category which is in the category table, defined by a category ID and the category name. So we have the categories and the products opened. And what I want to have is, I want to have written down the category name, or the column, and then the product name. So I want to have the category name in front of my product written out. And for that, I first say, okay, in this select, I have the products table involved, because we are still talking about products, and the categories, because in categories there is the category name for the ID. And then I say where products category ID, because I want enough, equals categories category ID. This is a, and the next part is we just say and products supplier ID 2, because we want to see only the products from a specific supplier in this case. And finally, we add an order by clause, and now we are just we have all major parts of the simple selects now, which means the result set gets ordered by category ID, which in our case means we want to have we get an array where we have strings in, which have in the first part of the string the category name, followed by the product name, sorted by categories. Maybe I should execute them, because when we start to talk about all these statements, it's not so funny. I'm just disabling. This is the first query. This one where we want to have only all products which belong to a specific category ID. That was this, which is Chef und Kuchenmix, Bratwurst, Boysenberry spread, Original Frankfurter grüne Soße. I like the Louisiana hot spiced okra. But the next one here, this is the one we are talking about right now. It's condiments, column Chief Antons, and convenience Chief Antons. And that's exactly what we want to have. We want to have all products from a specific vendor sorted by category. In this specific case, our supplier only delivers condiments, which means we look if we can change the supplier. Okay, this supplier at least has two different categories. We see condiments and produce. So two different. Do you have some question about that query? Yeah.
Oh, not about that particular query, I just had another question.
Yeah, I just want to go into the query because SQL.
Oh.
And then I come back to your question.
Okay.
Yeah, somebody has some question about that query, which is basically we are joining here two tables because we have a major table and we have a category ID table from which we get the category name by category ID.
It's not possible to use a set relation to or anything like that.
Huh?
You can't do a set relation to command like with this.
I can create relations between work areas, but set relation is what the Isernhagen uses to describe these type of correlations.
Okay.
That's what I mean. I mean, the set relation in the Isernhagen I have not explained before because many Clipper people don't use the set relation as a command for historical reasons. But set relation is exactly this, which means I describe how a primary and a foreign key correlates. And in the Isernhagen then what happens when I navigate on, let's say, the table with the primary key, all related tables with the foreign keys will follow the parent table, so to speak, when I access this child table. But we're talking here about SQL, and in SQL we are generating result sets. We do not navigate on the table.
Yeah.
And so we describe this relation here and get a result set.
If I understand correctly, then we use just a DBF table, which is on the local disk.
Yeah.
But if I use the same tables using ADS, via ADS DBE,
Yeah, yeah. Mhm.
yeah, where is the query actually executed, on the client or on the server?
It depends on this query is executed on the client. When I do this, when I write via or session, then it's executed on the server.
That answers my question too.
Because the point is we're here talking about Universal-SQL, which is about in-memory, which is about our work areas. When I want to have a remote execution, I need to use unified SQL. And the difference is the into clause is substituted by the via clause. And that's the...
Can I combine these two?
Yeah.
So via a session into a data?
Yeah. The point is, you can combine what you want only by using a subselect, which we have not dealt with right now. You can, when you want to have it as an atomic operation, because the point is, what you can do here is, you can, I mean, if I use here this table as a local storage, or if I create this select against the remote storage, then I have this work area, and then I use this select on my work area. Then the problem is, the two selects have happened at a different point in time, which makes the resulting select incorrect. What you want to have in your case is that the the result sets from different data sources are merged together at the same point in time, so to speak.
No, what I actually want is the result of the ADS server into an array.
Yeah, okay, but that's very easy. Then just open up the table of the ADS server or create a select against the ADS server.
Yes.
And then use the select against this work area and move it into an array. But then you don't need to...
But can't I put in between, just before the into a data? Can't I put there via O session?
9, because this makes no sense. What you can put is here, you can select from, let's say this is the via O session. Here needs to be. You need to put it here. It's a subselect.
So what you're actually saying that you can create one query with combine a local data source and a remote data source.
Exactly. Basically, you can have even more complex queries because I can also write with a data. So I even can create a select statement against an array of objects, a subselect of a remote data source, and our local DBF tables, and then create a result into an array. This is all legal and this is by design, and that's why we think this is great, because it allows you to write almost all your traditional types of logic in a relational-oriented way. So you can start to think about data and know more about how to write this algorithm. It will radically reduce the amount of code required to write business logic because of this unification of in-memory, remote, and so on.
Steffen again.
Yeah.
I replace the into a data as array via O session.
Okay.
What is the actual technical, what is the result of that statement?
Work area.
A work area.
Yeah. The result of that statement is a work area.
And that can only be a work area, that can't be an array.
You can move the data of the work area into an array.
Not straight away. Not straight away as you're doing here.
You can't put an as array and
But what I can do is, let's put that, you want to do this.
That's
what
what
you want. And,
yeah.
So two-step. It's a two-step.
I can create it in 2 steps. If I like, I can even create it in 1 step because it would be legal to write this statement inside this statement. But it's exactly what SQL becomes a mess. Yeah, that's the whole point. I mean, how much of you have dealt with SQL in the past years, and how complex have they become, these select statements sometimes. And that's a big problem of this language because of its declarative nature and its abstraction. It's sometimes very, very difficult to create, even if it's describing the what you want, to create readable statements. It's becoming sometimes hard. And I think that's where this solution can help, because the great thing is you don't need to have the complex SQL statement. You can, like now we have split it. SQL people would have written it into one because they have not this temporary storage. They create views, they create cursors, which they then reuse and so on. But basically you have this for free. So we can look into this in a practical way when we go to the Unified SQL, because right now we are still at Universal-SQL. When is the official end of my session?
Whenever your talk is finished.
Yeah, but my question was precise. I asked about the official.
5 minutes.
5 minutes? Okay. So let's go through this a little bit more. So this here was understood. Here we have a function, it's called load ID description. It simply creates an array of objects. In our case, an array of objects. We load the categories table into memory represented by objects. And what we are doing here now is, instead of using the two DBF tables on disk, we are now doing the same join like here. But instead of having products and categories as a table, we are now using an array of objects. And you see here in this, it's the same notation, because from this select statements perspective, the member variable of an array becomes a field in the select statement when you create code. So you don't write something like this. You are dealing with fields. So in fact, the array of objects gets boxed into something like a work area. And then we can use it and we get the same result. This is now the simple solution of, you see here, via our session, we are now at Unified SQL. We are connecting to a remote data source. It's clear because we're using here the Postgres database engine. And this is again two simple selects, nothing special, where country equals Germany. Now we were with customer orders. I want to see the orders of these customers. It's again a gem. And here we go that. Oops. And so now we this. I used the text mode browse because it was easier to use than the GUI policy. But you see, it's these different select statements, and also even though it's 122 records. Okay, this is because I didn't wrote it. 11, 122. It's different orders IDs. This is the query about the orders. So this afternoon I will upload the samples in the data model, and then I can use this code and play with it. And we are here, so feel free to ask questions. As you see, the VX environment included in the 2.0 to perform syntax highlighting if you load into SQL files. Unfortunately, IntelliHelp and IntelliSense is not working right now, but finally should enable to have the SQL support for all that too. This is the data model for the Postgres SQL server. 2 words in that context. The data format we are using with the Postgres SQL server, and also the storage format for the internal SQL engine in the 2.0 runtime, it's UTF-8. So in means of the storage, we moved to Unicode consequently. Where we didn't move to Unicode is in means of the UI, because of the Windows APIs and the platforms we are forced to support. At some point in the future, we also will move the UI completely to Unicode. We have now only the storage, which means Postgres and SQL. just a quick walkthrough. The benefits are clear. When we think about the capabilities, it means of in-memory as a Universal-SQL and Unified SQL, and how we can combine it. We can write lesser code. We can write better readable code as long as we avoid complex select statements. But then, the good thing is we don't need to do that because we can break them, or we can combine them with our knowledge about ISAM, which sometimes makes a lot of sense because, for example, when you have trees of information, or when you have unstructured data, it's very difficult to handle that type of data with a SQL system because it relies on the idea to have normalized data, to have data in a specific way, in a guaranteed way, while unstructured data is unstructured by nature. And trees or other graphs to be represented in a relational database and gathering data from a tree makes queries enormous complex, and it's very difficult to really write select statements in a generic way to have an infinite tree really traversed. For that, hey, just use ISAM because you can mix. And that's the key point here. Any of these result sets are fully ISAM capable, so there is no restriction. You can mix both, and you can actively decide which syntactical and semantical flavor works best for a specific case. You need to experiment maybe at the beginning clearly and find out what's the best case, but don't try to create anything in SQL. That's the whole message here. And it's clear because when we talk about SQL in means of Postgres-SQL, we'll talk about client server. We have better multi-user performance and higher reliability. But also, and that's another point when we talk about SQL Server systems, always think about, in the past when you have the files on the file server in the network, this file server doesn't need to have a lot of main memory or a lot of CPU power or whatever. Hard disks was the question, and that's it. When you talk about using SQL servers in your solutions, you're creating not only a single point of failure, which means if the SQL server software crashes, all your workstations are no more working in means of data access. It also creates the problem that the workload is concentrated on the server. Your workstations can't reduce the workload, basically. Of course, with Universal-SQL, like we said before, you can split. So you can get, let's say, some data from the server, put it into your local workstation's main memory, and then perform the query. It's a good idea because then you can create workload on the workstation. Because one of the major problems people have with SQL systems in place is they get overbooked. They get too much workload from client workstations, and administrators are always fighting against that fact. So much about this. This is it. I'm way over time. No, only 6 minutes. So finally, I want to conclude with, first, SQL is a data access and management language. It's not something which is substituting Xbase++. So don't fear about it. It's like ISAM. Xbase++ is a forced GL with SQL and ISAM language features and capabilities. Great, so we don't care about this anymore. For us, it's normal. No? And we don't differentiate in means of quality. We use the best tool for the best question. And as a matter of fact, sometimes SQL leads to better performance and readability, and sometimes ISAM. So there's the balance. The world is great. I thank you very much for your attention. Any questions?
Das war passend.